is more annoying because we have to have a common denominator. So it is going to make our life a little bit more challenging. So now here's the other piece though. Once we now do this common denominator, don't now go complicate multiplying and dividing and get common denominators for those. That absolutely, you do not want to waste your time doing that. You won't get the problem right if you do that. Multiplying and dividing, no common denominator. Don't waste your time. Addition, subtraction, we do. So let's just jump down to part A. And these are, the denominators anyway, are monomials, which is great. So as far as the 4 and 6, what number do they both go into evenly? Oh, smaller. Who said over, Preston? I heard 12, yes. So numerically, and the x's are already a match. So numerically, I just need each of those to be 12. So to get the 4 to be a 12, I multiply by 3. Why do I have to do it in the numerator and the denominator? Correct, because I'm basically multiplying this fraction by 1. I'm going to change its appearance, but I'm not changing the value. So I'll just keep it separate. So that's 3 times 2x minus 5. 2x minus 5 is a binomial. Plus, and this needs to be multiplied by 2. So that's 2 times 4x plus 2 up top. And they're both now over 12x. So let me ask you, if I have 2/9 plus 3/9 numerically and I have a common denominator, what does that equal? 5/9. So what did we do with the denominators? Did we add them together? Absolutely not. So the fact that I have a 12x here, that's going to stay the same. What I do need to add together are the numerators, which I can do, but I have to distribute first. So I'm going to get 6x minus 15. And I'm distributing a plus 2, so that's plus 8x plus 4 all over 12x. And then when I add and combine like terms in my numerator, that's a 14x minus 11 all over 12x. And that's your final answer. Okie doke. Any questions on that? Because now we're going to move to binomials. Here we are. Again, where factoring is going to haunt you if you're not great at it. We are not going to look at those denominators and just assume they're totally different. We need to factor them first, because what you will probably find in most scenarios is that they already do share at least one common factor, if not more than one. So if I look at this denominator, what method of factoring do I use? GCF, pull out a 5, I'm left with y minus 3. Plus, what method of factoring over here? Very good. Y plus 3, y minus 3. So now you can see that they do already have one commonality, the y minus 3. Agreed? Okay. So what does this one need that this one has? What factor does this one have that this one does not have and needs? Y plus 3. So this needs a y plus 3 over y plus 3. And then what does this one need on the right that this one has but this one does not yet? A 5. So now you can just look at your denominators quickly. Both have a 5, both have a y minus 3, both have a y plus 3. So they are a common denominator. So it will be 4 times y plus 3 plus 5 times 5 all over that common denominator, which I'm going to put the 5 out in front just because that's... But once that denominator is common, I only need to write it once, and I can just kind of smush together the numerators. I'm just adding the numerators. And then You just need to simplify the numerator. You do not ever multiply out that common denominator again. You factored it, keep it factored. But your numerator we would simplify. So that's going to be 4y plus 12 plus 25 all over that common denominator. And then what is my final numerator when it's fully simplified? 4y plus 37 over your denominator. Yes. No. But I don't want you to make your life any harder than it has to be. Once you factor your denominator, just leave it factored. And the only reason we have to multiply out our numerators is because your numerators are actually what do get added. Your denominators don't get added. Your numerators do. So we need that to be all multiplied out so that we can add them. If it's multiple choice, they may put it as y squared minus 9 just because it's the common core and they want to, see if you can match it up. But if you're doing an open response, leave your denominator factored, only multiply out and combine your numerators. Okay? Any questions? Okay, we flip to the back. What's different about, we'll start with A, what's different about this one? Subtraction. Now this is tricky, and this is where I say put binomials in parentheses. A is nice because what's already done, already have a common denominator. So we just need to combine those numerators. And because we're subtracting a binomial, what do we have to remember to do? Nope, that's division. Keep change flip as a division. When you subtract a binomial, distribute the negative exactly. So this is going to be 3x plus 7 minus the x minus a positive 3, which is just minus 3, all over that common denominator of x squared minus 4. And then we can combine our numerator. 3x minus x is 2x. 7 minus 3 is plus 4. Now, back to Isaiah's point. This is not simplified. Can anyone see why? Nathan? Right, and some people are not going to see that right off the bat without my leading question, and even still with my leading question, people still don't see that even after hearing you say that. But the numerator is still factorable by GCF, pull out a 2. The denominator always was factorable, we just didn't have to do it yet because they were already common denominators. That's difference of perfect squares. And then what cancels? X plus 2. So your final answer is 2 over x minus 2. If you look back on the front side, we didn't have to deal with that. Number one, Isaiah, back to my point earlier, we keep it factored in case this is a possibility, but our numerator wasn't factorable, so there was nothing to be canceled. Same thing here. Our numerator wasn't factorable further, so there was nothing to be canceled. Maggie. The denominator usually is going to be factored anyway, though. The only reason we didn't factor this one is because they already were common denominators. But most often we start literally by factoring the denominators, just so we can see, okay, what do we already have in common in the denominators, and what does each one need? Does that make sense? So your denominators will almost always already be factored. This is just a weird one because it started with common denominators. I can almost promise you that your Common Core exam would not have one start with common denominators. Okay? So let's go to B. Cameron, what does my denominator here factor into? Yep. 2x minus 1, 2x plus 1, minus What does this denominator factor into, Aiden? 2x plus 1. So, as far as getting a common denominator, they already have the 2x plus 1 in common. What does this one on the left need, Evan? What does this denominator have that this one does not have and therefore needs? A 5. So we're going to give this a 5 over a 5. Now here is, again, why in this numerator, the binomial doesn't need parentheses when it's originally written, but I'm going to throw them in there so I remember to distribute. And then on the right-hand side, what does this denominator need, Maddie? Good. 2x minus 1 over 2x minus 1. Okay. So in my numerator, just to kind of clean this up, I've got 5 times x minus 3 minus 2 times 2x minus 1. Is that fair? That's my numerator. All over the common denominator. And then the only thing I need to multiply out and simplify is my numerator. So that is going to be distributing the 5x minus 15. And then I'm distributing a negative 2. We see that. Negative 2 times 2x is minus 4x. Negative 2 times negative 1 is plus 2. All over the common denominator. And then when I finally combine like terms, my numerator is what, Nate? X minus 13 over that same common denominator that's been following me through the whole problem. And x minus 13 can't be factored. There's nothing else that can be reduced. Good? Okay. Let's go down to, oh, I had a great one. Hold on. Try C on your own. Everyone try C on your own. So in case you haven't gotten there yet, I've factored each denominator, so double check to see that your factoring of the denominators is correct. And in the event that you couldn't figure out the second denominator, look up at mine and realize what it should be. Then keep going from there. Get a common denominator. So what does the fraction on the left need? x plus 10. Very good. And what does the fraction on the right need? X, what'd you say? X plus 2. Good. So once that happens, this is where you should be. And then all we need to do is simplify our numerator. So distributing x squared plus 10x, and then distributing your negative 6 makes negative 6x minus 12, all over that same common denominator. And then when you combine like terms, 10x minus 6x is 4x, over the same common denominator. Is that numerator, I'm suspicious, is it factorable? It is? Into what? X plus 6x minus 2. Good. So what happens then is we lose a factor. We can simplify that and cross off our x minus 2's. And that's your final answer. X plus 6 over x plus 10, x plus 2. Maybe in your space to the right, I want you to write down this example. This is the last one we'll do, so whatever space you have, write this down. And I'm pretending like I've already factored out denominators. What do you notice? Are they the same? What did you say, Bob? Right. The x plus 5s are the same, so that's great. But x minus 2 and 2 minus x is not the same. We need to flip the order of just one of them, right? Okay? To flip the order, you negate it. But you can't negate the denominator without negating the numerator, just like anything else. Whatever you do to the numerator, you have to do to the denominator. So what that's going to change this into is 4 over x minus 2, x plus 5 stays the same. But on the second one, it's going to be a negative 3, or we could just make it minus 3, but I'll do that. And then that negative 2 minus x will flip around to being just x minus 2. So that's kind of playing on that, switching the order of a subtraction again, if necessary, just negate it. Do we follow that? And that's how you would get the common denominator. Today, good study help? Oh, but then you could do the same thing tomorrow. What about when you, I know,